Hello everyone, I'm Xiao Gang. Now we will begin learning the basic concepts. First, let's talk about code standards. We must follow these code standards. In a narrow sense, code standards refer to the standards for writing code. In a broad sense, code standards are not simply about writing code. It may include how we structure the project, our naming conventions, the management standards for the entire project, our project development standards, and our optimization standards. Some standards for asset creation workflows. In essence, they are all standards. These standards are all conventions we have established. They contain a lot of experience from our predecessors. There are also some general industry standards. So what are the benefits of following the standard? It means your development efficiency will be relatively faster, because these are all pitfalls others have already stepped into, paths they have already walked. Then, among our team, each role performs its own duties, making collaboration smoother. Then, the code of our entire project is easier to maintain, iterate, organize, and refactor. If you don't follow them, what are the benefits? It's possible that when we ourselves are developing, we might not follow them as strictly. It might not be that we have to submit once every 3 or 5 days, then package it once, then set a version, then set the development date, then our naming. These things may not be that detailed, but we develop very fast. This is the advantage and disadvantage of not following the rules. That's about it. That is, if you go to work, you should still follow standard interface specification, because if you don't follow it, your colleague might physically fight you on the spot. Yes, okay, so we can take a look. Here we have a general development standard from EPIC. It was compiled by EPIC officially. Everyone can go through it one by one. This is a simple asset naming convention. And here is the code convention. Okay, we won't go through this document line by line, because it is quite extensive. Yes, it is also very comprehensive and broad in scope. So on our end, there is actually a video. There is a video that follows this practice for code standards. Everyone can take a look. We practiced for a long time. Just practicing with this video alone, we probably practiced for 1 or 2 hours. So everyone can check this out. Okay, and here's another one. Hui 200 level blueprint tutorial I recorded myself. Everyone can also take a look. It also covers the official documentation. However, this one is pure blueprint. It doesn't have any C++ in it. Okay, let's talk about our own standard. Talk about our own standards. There's also one from a community expert. You can click in and take a look. Our own standards. Let's start with naming conventions. When we write code, every file has its own naming convention. For example, if we inherit from U class, it starts with U. That is epr, then inheriting from widget. S widget starts with S. S widget is what we commonly call slate. This is the underlying layer of UMG. Then inherit from actor starts with A. Interfaces start with I. Nameplate start with T. Numbers start with E. Boolean variables start with lowercase b. Right. Delegates and structs all start with F. Then dynamic multicast. Single cast all start with F. Then what they specifically look like in the project. Let's just look at Lyra. Okay, this is CS5. It is something we covered in the previous few lessons. It doesn't need to. It has its own naming conventions, so it is not a U class. We can see this is a namespace. Right, this is an F class. It is a struct. We can Ctrl plus left click to enter. It starts with F. Then our usual naming convention. Generally, like a class, the file name of a class, it mainly describes this class. It is this class. You can see. Actually, you need to note that your class name has this prefix, but your file name does not have the prefix. Okay? The generated part here, it also does not have the prefix. This is a naming convention. If you don't follow this naming convention, it will cause compilation to fail, because we've explained that our UHT recognizes this prefix. Okay, this is a struct, right? This is a UILEI. Then we can look at the interface. This is an interface. This is how an interface is written. The interface requires writing 2 classes. One is the U class. One is the I class. We write the actual interface in the I class. The U class is only for convenience of reflection. Use this U interface to mark it. This is a standard interface like this. And this is the standard common, actually for enums. Everyone can look for them. Take a look. Okay, let me check. Can I find an enum in there? Let's look at another project. We have quite a few projects here, so showing it to you like this. In this chapter, we mainly focus on looking first. There is less writing, because by looking more, you will understand why it is written this way. Okay, here we have opened a project from Qiangfei. We can see that inside this spherical P, okay, we find this spherical public type here. Let's pick any type here. Okay, then we can see that here are some, this is an enum, right? This is a way of writing an enum. And it starts with A, no problem. Yes, generally speaking, this file name and what it contains is that one file can contain multiple classes defined in UE5. Yin, Yilei, To, Yilei, Cai, Tata. This name and that name, the file name and its name, actually do not correspond one-to-one, but we recommend that they should correspond. That is, one file mainly describes a core function, and there must be a core class, and then other things like enums and structs might be auxiliary to this core class. It is generally recommended to do it this way. Okay, as for this template class, usually like our Tarnfei, Temep, they generally start with T. Let me show you. I think it should be relatively simple. So I'll still go through them one by one for everyone. We can so search. Hey, see this tier? It is a host. Tadi, it is a template class, and the template inside can hold fstring. It is used to store some stocks or strings, etc. Okay, no problem. Let's continue looking further down. And this type define, of course, it is used to define and rename something. It means you should know how to do it. And this explains the reason. Because our UAT needs to scan files, so your naming convention is very critical. And this type and variable should be named as nouns. Then the method name is a verb. Actually, what this means is, what attributes do you have? For example, health points, magic points, then stamina points, then money. These should all be named. Then the method name, you need to change it like this. So this is a convenience in terms of English semantics. Then all functions that return a boolean usually initiate this kind of true or false. So we prefer to use this kind. That is, it has a sense of language at the beginning. So this is it's about the naming convention for function names. One thing worth emphasizing here, in Unreal Engine, we use the PascalCase naming convention, which means the first letter should be capitalized, right? And at the same time, the word after that should be capitalized. The first letter of each word should be capitalized. You see, this is the prefix, and then this like gameplay ability, gameplay effect, right? Interface, okay, but this is within our UE5. If someone writes code, you see, it starts with a lowercase letter. They might have switched from Java or C#. If you see they like using underscores and such, then they might have switched from C language. That is to say, and they are not a standard U++ engineer. UEC Jaji engineer. Then we can take a look. Let's open a library here. I'll make it convenient to give you examples. For third-party libraries, let's directly look at the project inside this wake-up. Should be no problem. Okay, this is a wrapper project for a third-party SDK. The SDK it provides as a Windows SDK. Then we can directly look at its header files. Okay, alright. You can see, its file names all start with lowercase letters. You will notice there is an underscore here, right? Okay. Take a look. This is its header file. You see, this one also starts with a capital letter. Oh, maybe, hey look, do you see this? Do you see? This one actually starts with a lowercase letter. But look, in our Unreal Engine, all our methods start with an uppercase letter. So in Unreal Engine, there is no such thing as starting with a lowercase letter. But sometimes there's no way around it. Sometimes there are special cases. Then we will also, that's for compatibility consideration. For example, you'll see I have a file here. Let me give you an example here. This is not... Okay, let's take a look. It should be this one. You will notice that there is a lowercase letter at the beginning here. This is to save on deserialization during network transmission. Therefore, this part starts with the lowercase letter. So these are some special cases. We will go into detail when we encounter them. Then, regarding the naming conventions for blueprints here, it is actually BP. That is for general blueprints. VBP material animation. Things like an animation blueprint. You all must have used blueprints before. This part will not be explained in detail. We will show you a list later. As for the method called from C++, we really like to start it with K2. Then, through this red marker, that is, through the mentor property and U property, assign its display name to it to block this K2. We can simply search for one. We search directly in this Lyra. This is usually how the engine likes to write it. Is this him or not? We don't match forward. Matching forward like this, it might not find it. You will notice, care, right? This place, right? Manta, display lamp, send a customer event, right? Event. So this care here is for when we write code to let it know that these are things called from blueprint. So this is a naming convention. Let me briefly explain the life cycle. For Chestum, you can check out Master Dejiao's subsystem tutorial. I just briefly mentioned it here. If you come from a traditional C++ background, there is a situation where we need a singleton. For example, we have a scoring system in the game, or a global scoring system, or some unique object. So we need a singleton. Then in our Unreal Engine, don't use the traditional C++ way of writing a singleton. I'll just show you one here. C-judge singleton, like the lazy initialization style or the eager initialization style. Don't write it that way. Singleton. This singleton. Because in our UE, there is something called a subsystem. What is this subsystem? Let me briefly explain it here. I'll just open one here. Let me check if it's written in my code. If it's not written, we'll go into more detail later. I'll just rely on something here. Something I can show you directly. Let's just use this. Okay, this part, it inherits from Subsystem is divided into many categories. We'll only cover this category here. That is this U subsystem. It inherits from UObject. UObject is our top-level parent class. Right, then it will help you instantiate it. This gammas, instant subsystem thing. That is to say, there is only one globally. It will be at the start of the game. Help you instantiate it. At the end of the game, release it. So the corresponding ones are these two functions. Disinitialize and deinitialize. So, by doing this, we don't need to consider the life cycle of this object. We just need to use it at the right time. So this refers to the meaning of the system. Okay, so after simply knowing about the system, we will talk about then regarding structs, we need to manage them through smart pointers. Smart pointers are for a beginner quite troublesome to understand. But if you have used smart pointer in C++, it's not so bad. That is to say, we try to just when we produce an object, when this object should be destroyed, we can control it manually, or we can control it automatically. Of course, we will adopt automatic control. So we use smart pointers to control it. If we want to control it manually, traditionally, we might have to delete it ourselves and then release memory this way. Of course, in a game, frequently allocating and releasing memory is a very dangerous operation. So in UE5, we don't use new and delete. For overfare, we definitely don't use new and delete because overfare has already abstracted new for you. We can only use new object. Okay, so sometimes in our third-party library, when it comes to the third library, we have no way. We might need to use 6 deletes. You don't need to worry about this part. After you release it, just remember to free it. Okay, let's look at the standard comment format. Here we provide a function. This is a function I wrote so this function of ours, the declaration here is the same as a normal declaration, than this U function. We'll talk about it later. It's a macro, and the macro mainly concerns this U function. It marks this function, allowing this function to let the engine let our reflection system, let our engine know that there is such a function. When we comment on it, we first need to do it this way. In the first line, in these lines, we should first state what this function is used for. Then we comment on each of its input parameters individually, the parameter names, and what their actual purpose is. For example, this first object is called the context object. We often use this context object to represent the overall situation of the entire world. We are inside the editor's world, or inside the game world. That is, we need to clarify the context of this world. Then the following are some strings and structs. They respectively represent how this information is used. Finally, the object we return. It is a pointer of type UObject. Yes, that's right. Pay attention. Generally, our UObject can only be used with pointers. Understand what I mean by this. Our UObject can only be used with pointers. You cannot directly declare a UObject object on the stack. Okay, finally, this is the return word. Then the first function. This is the marker inside this red. It has different functions. So this place, the first function. This blueprint, it only has two variables. One is the metadata. One is its function. The function is the one we actually need to use. It means the blueprint can use it. Meta is its metadata. It is mainly used within our editor. So first, we made some definitions. This is the object assigned by the world context. This way, inside the blueprint. You often don't need to pass this context object, but sometimes you'll see some functions that ask you to pass a self. Then it's very likely the world context. And this is the name displayed in the blueprint. This is a keyword. You can find it when you right-click and search. And this category is just for classification. This place is divided into a 3-level menu, meaning it will be categorized level by level. Okay, this blueprint, internal use only. I don't quite remember this one. This place. Think about it. This seems to be related to our one-step node. Don't quite remember. Let's just skip this part. We'll cover it later when looking at the original data tags. Then, that is to say, when you compile, when you define a H file, we usually put the copyright notice first. Then, if it's H file, you must include #prime once. This avoids problems. Then for H files, don't include. You'll notice that when I write files now, write things, we need to add a copyright notice here. If you have ever listed a standard plot call on the EPIC game store, you will find that it requires the first line of each source code file to clearly state your copyright notice. So let's take a look at Lyra. Right, corporate EPIC game, and in test means company. That is all rights, meaning all rights reserved. This is a copyright notice. Then next we have program runs. Actually, according to standard commenting conventions, we should also indicate on the class. Look at the standard comments. In fact, if you look at the engine source code more often, we can click into it, our engine source code, our best learning aid. Because in many cases, we learn by reading the engine source code. That's because the engine source code often includes comments for you and provides usage examples. We'll write something in the engine code like XXS. When you see it, you know. This is a demonstration for you of how to use it. So the engine source code and comments. The comments in the engine source code are our very best learning companions. Okay. Next is the official documentation and the official examples. Okay. So let's pay attention. In our collaborative work, it means that many people should not modify one blueprint at the same time. Doing so will corrupt this blueprint because you have made changes or someone else has made changes. This creates a conflict in version management, and a blueprint is not like a text file. You cannot edit and merge it line by line. In this situation, you will either have to discard one party's modification, especially the level blueprint. Many people often operate within the blueprint of the same level. In this case, only one job can be kept. So, for this kind of level blueprint, how do we handle it? If you've worked with blueprints, you'll know. Sometimes we split a blueprint and a level into many levels. For example, a level for lighting, 太第一颜的, and then some other miscellaneous audio level. Then the lighting artist manipulates the level within the lighting setup, and the audio engineer goes into the audio level to manipulate audio objects. In the end, it all combines into one level. So that's how it's handled. So actually, In many large companies now, there is a development method that optimizes their workflow. They can go beyond the same level blueprint by building a set of using this word preparation, which is an actor with file-based functionality, and then through another method, that is, through another platform network. They don't directly modify the blueprint. Through another platform network, they record your brush operations to paint these blueprint objects on top. This is also one approach, but only large companies have it. Then secondly, pay attention. Don't frequently 突发 I file or keep changing it back and forth when someone else pulls the code. Pull the code. INI conflicts. That gets really annoying. And remember to ease in and ease out. That's the situation. And there are also some small coding details. Since we've already mentioned it, we can actually bring out our rotator. Its constructor. Its order is P7 plus row, but in Blueprint, it is ROP7. Please note this. When we write it, you can take a look. Let's search for it. Look, I'll click here. Let's wait for it to navigate over. See if it can navigate. Do you see it? PG Yaru. It's not Rupai Jia. YX. This is a small detail. I wrote it here. Quite interesting. Then, regarding forced inlining, actually, we use forced inlining. When we have a large amount of code, there will be this kind of gate operation. We can see. You will find, actually, the engine really likes to use forced inlining. The benefit of forced inlining is that it takes the source code, the code of this function, directly inserts it in for you. Execution will be very fast. But if you are inside forced inlining, you need to write very complex code. Generally speaking, if it exceeds 5 lines, you should not write it inside the forced class. Do not loop inside the forced class. These operations, that is, the forced class has its advantages and also its disadvantages. That is, you roughly know that methods that directly retrieve a certain value, using the forced class for these is very reasonable and convenient. Okay, then if you don't consider code bloat, in fact, we would create many files to classify and execute each one. You have written Blueprint. You know you can write all the logic onto the character itself, but you can also abstract a lot of things from this character. We abstract out a storage component. Abstract out a health component. Abstract out a skill component. Abstract out a special effects component. And in fact, our gameplay levels can also be abstracted. You can write all the code into the level blueprint, but you shouldn't write it that way. You should separate the logic. Write your game rule logic into the game mode. For example, sec game has 10 waves of enemies. Then, the spawn time for the first wave of enemies among these 10 waves. The spawn time for the second wave of enemy. The spawn time for the third wave of enemies. These spawn rules determine which location they are generated at, so these should be written into the game mode. This place is mostly accurate. The game mode only exists on the server. This is something to pay attention to when developing online games. Many people miss this. Then, our game state is for storing our data. Then our player controller is for controlling the user's input. Player state is for storing user data. HUD mainly manages our UI. You should have written this in Blueprint before. This is a review for everyone. This is what we offer. You can use forward declarations. This way, you avoid having to wonder. Include too many files in the CPP. This speeds up compilation, avoids code bloat, but sometimes forward declarations can cause unexpected errors. Anyway, the most common mistake you make is, with the reflected struct, you include the header file. Understand this sentence. It refers to things like JS struct. If you do it this way, it won't correctly link the reflection files, so you still have to include it. So this is a trade-off between forward declarations and including header files, so we can actually see which situation is better. Anyway, our recommendation is forward declaration. Because we look at the official project, actually, we directly in this place. Because forward declaration can avoid many problems, we find this character. Let's look here again. Take a look. It seems we didn't see it here. There is also a forward declaration. See? He forward declared this usability system. Forward declared, right? And then his actual include is in his CPP file. This is his CPP file. Include here. We talked about it earlier, how he solved this annoying header file problem. It is determined in builds. Later everyone. You will see it when you work on actual projects. Okay. Then for such virtual methods or overridden methods, you must write this override. Many times it is fine not to write override. But I recommend you always write it because you will have problems when you run into trouble. You just realize that it's better to write this override. For example, if I make a mistake here, I write it as getAbilitySystem here. then it will report an error because its parent class does not have this method because you write override. Just a simple example demonstration. Okay, then actually, let's look at the engine. Look at the engine. For this kind of interface inherited from the parent class, the engine will write it like this. It indicates that this series of interfaces are all interfaces of the parent class. I override them in the subclass. I put all of them here. This is a very good commenting habit, a coding habit, okay? But we usually don't write it this way because writing it this way is too troublesome, and when this T map equals, when we go to final, it might sometimes crash. I don't know why either. I encountered it before, but I'm not very sure. We'll verify it again for everyone inside the container and pay attention to the log, this management log. We will also emphasize we often print logs. In UE5, it's within the shadow. You will see this log. Right, there are some display levels. How are these controlled? Actually, when we write the code, we control it through a macro. Actually, if we want to summarize, this part is also very simple. Okay. There are also many options here. We won't go into too many. See, it's just, we'll talk about this log later. Look like this, each level. Which log is this? Which level? What content was output? And some content. We need to perform character replacement. So we wrote so much in a row below. Okay, then let's continue looking further. Okay, then that is the meaning of this sentences. Don't write nested for loops like that. It looks terrible. Try to use extraction or inversion methods instead. Sometimes we write low-level code. Can you write that kind of code? These are things you'll write after more programming experience. Beginners can't manage it. Just the use if statement, that's fine. Use switch statements if available. That's also fine. And the last point is the most important. This is a common mistake many beginners make. That is, you perform CRUD operations on game objects outside the main thread. Congratulations, you will definitely crash. I strongly suggest you crash twice right now. This way, you'll remember it deeply. Let me give you a simple example. Some people, they have a thread and it reads data from the database, or they've wrapped a network library, and then this thread gets data from the network and directly modifies UMG, directly modifies our UI. Congratulations, crash. It directly modifies the actor's position. Congratulations, crash. Then you directly write logs. Congratulations, crash. That's how it is. Anyway, just know that when you're if you perform CRUD operations on these things in a non-main thread, it will crash, that's all. Of course, there are many special cases. You can take a closer look during the thread section. Okay, then this is an asset. It's actually categorized and placed. That is, we open one here, this asset, as you can see, it is very clearly divided here. Which class does what? For example, this kind. Camera, obviously it's a camera. It's also for robots. This is related to input. GAMISC, cool, is related to special effects. It is a categorized way of thinking. You declare an asset. Think about what this asset is, where it should be placed. Okay, this is a common naming convention. Everyone, take a quick look. We mainly look at this level. The naming convention prefers starting with L. Materials start with the right, and textures start with T. Blueprints usually start with BP. AQA component AC. NP and blueprint ABP. Then for data table, we use DT. Data table is basically UE5's Excel. Right, no problem. Okay, just take a quick look. Should be fine. Okay, finally, let's take another look at our project architecture. Okay, actually, we just created one. AC GAPROS project. So after creating it, that's about it. This is a Rava project. Currently, this is its project structure. In this structure, these extra deployments we generally don't use. It usually includes some external dependencies. We don't usually click to look at this. It's not here. Maybe take a look to see if I have it here. It might be blah. It might just not be there. Right, we closed it. Quangle guard operation. Closed external dependencies. Maybe there's no way around it. Then let's take a look. And here, config is where we put the configuration file. Source is where we write the code. Below are these modules. Okay, generally, note that in the Lyra style, it has two modules. One is the main game module, the other is other modules, like Lua editor and such, and our game project name is actually called Lyra. This part is a bit special, because the project we created are ourselves the name of our main game module piece the same as, okay, alright, so next we will, everyone please, create one here yourselves, a UEC plops project. It shouldn't be a problem, it's quite simple. Let's continue with the next topic. Here we created a UEC class project, so it actually has a uproject file. Should be the one we created earlier. We'll just put it here, local here. That's it. Then we open it with VS, like this. Okay. Then what does each parameter here mean? We mentioned it to you earlier. That is which modules are in this project, this loading phase, and additional dependencies, the environment it uses, then the name of this module. If you have two modules, you should write it out here. And this place might depend on some plugins, and this is associated with which versions. This is a category graph. This category graph might not be used much. This is a version number. The file has version numbers for several file categories. If we continue looking at the documentation, actually we directly pasted here. This thing called Push's Dequity port. Its location is in our engine's masters project under the runtime module. This module's public dependency file. So let's click in and take a look. Alright, okay, let's just open any project. Let's open this one. I have a lot of memory. Yes, a lot of memory. So I have 64 gigabytes of memory. So it doesn't matter how many I open. If you have less memory, it might not be very convenient. Okay, let's find runtime. Okay, then let's directly find this project. It's actually very close. Many of the modules inside are quite interesting. Hey, I see slate. Let's find this project. That's it. Then here, find this project discover. Hey, there's also a module lifer here, right? So we've given it to him probably. And this place is a vision. That's it. Plugins. This is plugins. Take a look. It should be project discover. Okay, good. So here is a series of these English comments. He wrote so much here. Actually, it's just the engine's version number. This is the category description for the module plugin displayed here. And then the target platform he gave. Then these are some other parameters. Is this an enterprise project and actually these things you can get these things from your upreg. Yes, that's completely fine. You just need to reach the struct. Okay, then let's continue looking below. Then let's mainly look at this. Here it talks about this again. Here it talks about module plugins. Let's take a look. Yes. Let's see what else is behind. Okay. Then let's first explain this operand to everyone. Okay. If you notice, actually, within our plugin, it also has this operand. Good, operand. There are slightly more parameters here. This part is the tar, externally dependent plugins. It is a module within the plugin. Then, whether this is installed, then whether this is a test version, whether it includes content, whether it supports this, that is, this means contact. The URL for contacting the author. This is a URL for the marketplace. The marketplace is special. This is not a URL. It is a marketplace. Unique identifier ID string. This is the link to the document. Who created this as well? Do you know this company? EPIP created the EPIC company. Then who do you need to contact? Just find this URL, and this category is URL under this, that is in the plugin category. You can see right here, this category here, UI, placed under this, and here's the description. And then there is a good name. It's the other side of the coin, alias. Let's talk about, and this is the version name, and some things in this version, and its corresponding item. Actually right here, it should be at, let me think. It should be a, here, there is a plugin descriptor. Okay, this corresponds to the series of things we just mentioned. Now let me teach you an important piece of knowledge. Sometimes this plugin cannot be used in Blueprint. It might be because this feature is enabled. You need to enable by default. Just remove it and it will work. You can see in my plugin, I have done some processing. Then, this should be considered core knowledge. Here, I changed enable by default to false here. Note, change inspire to false, then re-enable it in the Pascal. Re-enable a plug tar in your project. So this plugin can be used in blueprint projects most of the time. This is how it's solved. This knowledge is quite core. I think there's no one on the market who would, very few people mention this area of knowledge. Okay, so let's continue. Let's continue. Take a look. Okay, so these are some parameter descriptions. I'm telling you right here. Take one last look at this position. You can come here and take a look. Okay, then let's take a look below. Then let's look at the other two files. Let's look at this build.cs file and the target.cs file. Actually, before this, yes, let's just look at these three files. Previously, we learned that after creating a new project, it usually looks like this. Look at this one. Look at this build.css. It specifies its PCH here. We usually don't touch this. So when would we touch it? I'll explain in a moment. This was mentioned before. That is, this DUNU module. If you are a public dependency module, then when others depend on this thing will be included. These modules will also be imported. Past means you depend on it. If others use it, you don't care about it. That's the situation. Okay. Then let's talk a bit more. Expand a little further. When it comes to plugins, we can take a look here. Let's use my plugin as an example. It's the most convenient. This plugin is on GitHub. The test version is the same. That is, the basic content is the same. Then what we need to pay attention to is how should we look at this part? Let's first look at one module. Let's first look at this link module. Here, you'll see that it's public, can reference so many dependencies and then so many private dependencies. That means after you reference this module, these modules are actually all imported because within this module, the interfaces of all modules are exposed. So here it directly imports them for you. And these modules are private. That is to say, you only using the module I have on the same day. And this is a variable of dynamic load module. We can ignore it. This thing is generally not used much. And that is to say, when building CS, we can distinguish. That is to say, if under different axes, compilation targets, that is the target platform, when it is different. If compiling for Android, we put the screen at this module, and that's roughly what it means. So this is the role of build CS. Now let's look at another one. Look at another one here. Okay, so actually what do these two things solve? We explained earlier. These two things are meant to solve. When others include this file, include the files under this ASRG, these module files, there is no need to include these folders. You will notice that you will notice that this entire sheet is all file names. Why can it find these corresponding file names? Because it is clearly hidden in this public. Under your folder, if you don't write this, then you need to add the name of this folder because we know the plugin's public. It's public by default. They usually search under the public of each plugin. So these two lines are to solve the problem I just mentioned. Then the second meaning of this module is to specify this path because in this place it needs to be written like this to find this location, and this thing is to solve. When I include it in my public, his header file, so it is written like this. That is to say, when he includes this file, we need to write it like this so that he can find this header file. I have used this writing method for a long time, and it is very stable, so everyone can feel free to follow my writing method. See, write, and there is no problem. Okay, let's stop here for now, because it involves too many third-party plugins, this kind of content. Okay, so we finished explaining this target.beam.cs. Actually, target.cs, we should have covered it in the previous lesson. Since we happened to come across it, let me emphasize it again here, because it's very important. So emphasizing it twice is perfectly reasonable. So target.cs determines what target we can compile into, and this compiles into a blank game project, and this part compiles into a game project with an editor, right? And this part specifies its build, and some include versions. Then these specific pieces of information, you can click in and take a look at this target rule. The advantage of this is you can directly use the attribute plus component to enter. it tells you what these options are roughly for, okay? So actually you will see in the levels build series, a lot of work is done. I'll fold them together here first. Alright, okay, let's first look at its main module, its target.cs. You will find it has written a lot of things. It calls a method here because it has extracted some common things. Okay, there are various methods here. That is what package you want to build, whether it is a test package or a release package. Under different circumstances for each package, you need to do some work. But this target.cs is for doing such work, generally speaking. We just write it in our usual way. That is, we usually don't write such a complex target.cs. So these two CS files explain it very clearly to everyone, and then note the editor here is like this. But you will find the others only include this scan because only the editor needs the editor module. You can understand this sentence, no problem, right? Okay. Then, if we continue, finally, let's take a look at our module file. This module is the module we created. Okay, generally this module header file is not needed. Header files are generally not needed. But I like to write it out. This way it's more complete. So here it directly writes one. We just implement the default gamma module. Nothing else needs to be written. And actually in the plugin, let's take a look. Each of my plugins actually has this header file. And this is the plugins module because it's not the default. We can take a look. Let's just do it this way. See, here we can do some things within the module. What will we do? I usually do resource copying. That is, if your plugin depends on a third-party library, third-party SDK, some third-party images, or impression text resources, it is not done in the build.cs file, but the loading of your library is done here. If you have created a dependency plugin for a third-party library, we will load it here. You can take a quick look. It should be fine. We'll go into more detail later. I'm just a bit afraid that if I tell you too much, you might feel a bit intimidated. This is very... But you don't need to be afraid. The knowledge I'm telling you about is all advanced knowledge. Yes, you can see that in this module, we briefly showed it through the platform. This third-party DL, that's roughly how it's used. It's relatively simple. This is the module. Because we are the game module, we don't need to worry about it. And this is Lyra's game group module. You can see it doesn't use this module here because it customized its own. So here he replaced his name. As for the closing remarks here, this part might have been changed. Move this section about the project. We move it to chapter 3, but it doesn't affect anything. Overall, the basic knowledge is pretty much like this. Next, we might start talking about the official documentation. Let me show you the following content. We can go over the official documentation. Actually, there are still many concepts later. Still quite a lot. Okay, we'll try to cover these basic concepts. In this chapter, this article will get everyone through it. Then after that, we will move into practice. If you really want hands-on practice, just go to the official Bilibili site. Check out my personal space. There are over 800 videos in it. All are hands-on practice. All are coding. I usually only cover the essentials. Only the core concepts. I don't usually do this kind of basic overview. Going through all these concepts for you, I only talk about what I use, right? Okay, so this video has been going on for 40 minutes. And that's it for now. Thank you all. Please don't hesitate to like, subscribe, share, and donate to support the Mingjing and Diandian program.